just move this out of the way and we're ready to go. So, hi. Yeah, I'm based in Vienna. It's slightly past midnight, so I hope I have all the energy we need, but let's see. It's a great topic, so it should be good. From containers to Kubernetes operators. I'll skip over my further introduction because, well, I've already been introduced very well. I normally just say like I'm a developer advocate, so I speak about the good stuff that we do at Elastic. So if you've never seen our stack, this is what it looks like. And while my examples will be about our stack, because that's the operator that I know best, it will generally apply to what lots of operators do in data stores, because I want to focus on what is like important if you want to run a data store first on Docker and then potentially on Kubernetes as well. Like what are the different pieces that come into play and what is important there. So I will totally focus on Elasticsearch because that's where the state is, and state is always what makes your life much trickier than just the stateless components. So normally, if I would do that in an in-person audience, I would just ask who is using containers, and I would assume pretty much everybody would raise their hand. If you then ask like who is using containers in production, it's probably like half of those using containers in general. And then there's always the tricky question, who is actually using containers for stateful stuff like any data store, relational, non-relational, it doesn't really matter. As long as it keeps your data and you want to keep that data, they're all the same. And that's then even a smaller subset. And then the question is always why and how can we improve that, or is that okay anyway? If anybody is using our containers, let me know if you have any feedback or want to discuss any specifics afterwards. We're always happy, or I'm always happy to see people using our containers, but what I will tell you is pretty broadly applicable anyway. So what I generally want to cover is, we talk a bit about Docker images and why they're the foundation and why we build them in a specific way and how that influences like the rest of everything. We will more or less gloss over Docker Compose because I think it's mostly for demo setups nowadays, and we have mostly given up on providing any official solution around that. And then I will dive into Helm charts versus operators. Everything running on Kubernetes nowadays, those are probably the two most widely used approaches to actually run your workloads. So let's dive into that. So Docker, or actually, I think this would be the right image or logo for Docker in any case. And this is, by the way, also the size of your average Docker container nowadays. And ours are certainly no exception. So I think like the current Elasticsearch containers are somewhere around 750 megabytes or so, if I'm not mistaken, which is not exactly tiny. So yes, that is what you get as the Docker container. We have this internal saying from a colleague, it is from 2 years ago or so, that Docker is the world's most heavily funded college project, and stuff has improved since then. But this shows that stuff was not always as easy or smooth as you would want it. Like Docker was known to break APIs or break your stuff in various unexpected ways, or that the abstraction was not as strong and stuff would behave differently on Mac than it would on Linux, which people would not really expect probably. So that's where this came from, and that's maybe there's still some frustration left in that. But there's no way around containers. So we always refer to containers or Docker images as the new zip format. So when you were downloading software in the past, zip was kind of the ubiquitous way to get any piece of data or software. Nowadays, the most common approach for many people is to use a container. So obviously there is no way around it. As a company, do we have a strong preference for containers? Not really. It's just one of many ways. So if you prefer to have RPMs or depths or plain old TAR-GZ, or you're on Windows and want to use an MSI, or you want to use some automation with Ansible Chef or Puppet, those are all valid ways, and we don't really care. We try not to be super opinionated like how you should install and run our software, because you probably have a much bigger picture and it should just fit in with the rest. But we're definitely not trying to stand in your way. So if you say like, well, Docker or Kubernetes is the way we want to run stuff, then we will try to support that to the best that we can. So, but it's not without issues, especially around Docker. There are these things that people do wrong, and I sometimes call them fallacies that you run into again and again, and you need to kind of like reinforce the points to not do bad stuff. So root and don't care or not caring about permissions is one thing that we keep seeing every now and then, or basically Adam and Eve, like you could replace the snake with a whale, and this is what Docker has been doing the past few years. Maybe it's just run everything as root, don't care about permissions, and people were like, yes, we don't care anymore. If you've ever run Elasticsearch, maybe you know you cannot run Elasticsearch as root, just because we think that's a really bad practice for any server process. So if you would try to run Elasticsearch as root on Linux, the process would just system exit, and there is no way around that. There is no setting for that. The only way you could change that would be to fork the source code and comment out that system exit that we actually called there. But otherwise, there is no way around it. Though people have been requesting, let us run everything as root in Docker times and times again, though for us, that is not really an option. The other thing that we are also pretty picky about is like, you should have the right users and groups to run everything, and not just change mod 777 over everything and not caring about how permissions are set up. So we expect a specific user and group ID that our data is being written. Which then creates these lovely issues every now and then, and you don't need to read it all. The relevant section here is when people say like, I prefer simple fire and forget Docker containers, which I always picture something like this that you want to do with your data is pretty much this approach, where you really don't care what happens to your data. And we strongly disagree with that, because the images that we build are made for production, and production is the main use case. Of course, you will use them for testing, but like most of the decisions should be influenced by production. So avoid stupid stuff so you don't suffer in production later on, or maybe make it slightly harder upfront so you don't have the problems later on that you don't want to have. So that is where we are coming from. That production is kind of like the main focus. And this YOLO fire and forget approach is definitely not in like the intention of how we're building images. Also, something that we see every now and then there is, if you do not understand Unix, like permissions, for example, you're kind of like condemned to reinvent that approach poorly or fight them forever. So that's something we see. People say like, oh, just use Docker. You don't need to know anything about Linux or file permissions anymore, which is not really true, unfortunately. Another fallacy that we see quite frequently is latest. And that is unfortunately kind of like heavily reinforced by Docker Hub itself. So for example, if you go to the official Elasticsearch image on Docker Hub, also official is always kind of tricky, because initially it was actually provided by Docker Inc. and not by Elastic, the makers of the software. So official was always kind of tricky, but you can take ownership over those official images. So for example, if you do Docker pull Elasticsearch, you will get the image from us, except that this command here that is being referenced does not work, because we don't have latest. Because we think that latest is a really bad idea for any external dependency, and especially a data store. Let's assume you set up an Elasticsearch cluster with 3 nodes today, and that works. And then in a year or so, you need to scale it up, and you need to add 2 more nodes. And again, you add 2 more nodes, and you're using latest, just with the cluster that you have set up like a year before. And then the major version might be a different one. And then that might just break your cluster in production. And then people will come to us to complain heavily. And that's why we don't support this. And unfortunately, Docker Hub always shows this implicit latest here by not having a version number. We would love to have the latest version number here, so anybody who copies this command will just get the latest image. But you'd actually need to copy this, and then you need to look up which tags do we provide, because we don't have latest, because we think it's a really bad idea. So there's no way around that, unfortunately. Sometimes people say, okay, we get the major version. What if you pin the image that you get to the major version? Like currently we're at 7 or 7.9. Why can't you not say, I just want the latest version within 7? Should be the same major version number, so it shouldn't break anything. Fortunately, it's not that easy the way that data is written. If you write data on one Elasticsearch node and it might have a newer version than another one, the data might not want to migrate to that older version. And then you might create imbalanced clusters and it might just fall over unexpectedly again. So neither one of these approaches is supported. You will really need to pick the minor and patch level version for all your images. It's a bit more pain or work upfront, but it will make your life much easier later on if all the nodes are running the exact same version, and then you can just move all of them to the whatever other version you want to run. So we are strictly enforcing that versioning. Another thing we see every now and then is runtime mutation, that people just want to update stuff as they go along. Sometimes like you provide a shell script and it will automatically be run when you do that, or you just provide an environment variable with, I don't know, additional packages to install or whatever, for whatever reason people want that. But there are feature requests for that. We also don't support that because obviously the right approach for Docker should be that images are immutable. So obviously what you would want to do is you have a custom Docker file, you take whatever base image that you have, and then you install a plugin. And we don't want to run that ad hoc on different nodes. And then, I don't know, on one, the internet connection fails, or it just gets an error when it tries to fetch a dependency. And then you might run different versions of the base image. You want to have exactly the same image everywhere. So they're the same and you don't break your data in any unexpected way. And this is also the right way how Docker would run that. And for example, the only thing that you don't want to have baked into those images are anything around certificates and secrets. So dependencies and versions should all be baked into the image and final and never change. Other stuff that has a different lifecycle, you want to keep separate. So for example, if my TLS certificate expires, I don't want to necessarily rotate my image. I just want to replace the TLS certificate. If I need to rotate a password in a key store, I just want to rotate that key store and not the entire image. So for that, this example here just shows how you would generate a new Elasticsearch key store, and then afterwards you could mount that, for example, in Docker Compose here, but Kubernetes can do that as well. So here we would just mount that secret, so your version is totally independent from the secrets that you have, because they just have different life cycles and you don't necessarily want to rotate them at the same time. Another thing that we see every now and then is that people have very strong opinions about base images. We started off for Elasticsearch with Alpine, but ran into various bugs. Admittedly, it was like 3 to 4 years ago, and probably Alpine has progressed further since then. And NewCL is much nicer probably than glibc, but in our experience, glibc is just extremely battle tested. So we ran into various weird situations, like some bug that was only triggered if you had 4 layers or more and was only happening on Windows or so. Things that you really did not want to debug. We ran into those with Alpine a couple of times, and that's why we standardized on having CentOS images for everything. Because CentOS supports everything that we need in our stack, like we have Node and JRuby and Java, and we have a C++ piece for machine learning in there. And all of those were already built to run well on CentOS, and it's also kind of like the most widely used standard in operating systems that we encounter as a company. So that's why we standardized on CentOS by now 7 for all our images. It's nice because all our images use the same base and they just share the same base layer, even though it's not exactly small. CentOS 7 is pretty widely used, so probably you already have it and you don't need to fetch it every single time you need to fetch one of our dependencies. Also, the JVM is pretty large, and for Elasticsearch, we want to have the JVM. So if you have a very small base image or not, doesn't really make much difference, because the JVM plus our software on top will create a rather large image anyway. And like I said, glibc is just pretty well battle tested. The main downside is size. However, in our opinion, especially for production again, if you have 100 gigs of data in Elasticsearch on a node, you don't really care if you save 100 megabytes of base image or not. It doesn't really matter. Also, you're not going to deploy that base image 20 times a day. Like if you have a stateless application and you just redeploy it all the time, probably image sizes make a difference. But data stores, you won't deploy that frequently because they're not moving around that quickly, and there are no new versions released that quickly. Like we will only release a new version every couple of weeks. So even if you upgrade to every single patch level release that we have, you will only need to do that every couple of weeks for the few data stores or Elasticsearch clusters that you will have. So the base image size is not really the issue. What we actually found out what was the bigger issue is that automated scanners and false positives are a major pain in the butt. Because there are so many false positives, and we have people who are almost full-time working on just filing reports of why some security issue is not actually exploitable in our images. And that's why one of our colleagues just recently started an effort, and it will come out in one of the upcoming images that we have, that we will still base everything on CentOS, but we will strip out any packages that we don't need. So I think by default, CentOS 7 brings around like 170 or so packages in the image, and we use very few of those. So we actually kick out most of them by now, and it also reduces, I think, the size of the image by 150 megs or so. So from 750 or so to 600-ish or so, I think. So it does reduce the size, but for us, the size is not the main goal, but really having false positives from security scanners is a major thing that we want to avoid. Like I said, image size probably doesn't matter that much for a stateful image because you have so much data on it anyway, and you're not deploying it that frequently. Whereas if you have something that is stateless and you deploy it X times a day, then you might care about that much more. Also because you might just provision new servers and you cannot reuse any shared base layers there. So there the image size might make a much bigger difference. Another thing that we are about to release soon are Red Hat Universal Base Images, or UBI. They are important in mostly the US federal space and to be certified on Operator Hub by Red Hat. Those were, I think, the main drivers why we're about to release UBI images for everything that we do. And those are also a bit smaller than the full CentOS images because we are using the UBI minimal ones. So these will, I think, in the next minor release, we will have those out for all our products as well. So you will have more choices. We support ARM64 as well nowadays. So there are already multiple base layers that you can pick from. One thing that comes up every now and then is that people ask for Windows images. Not sure if anybody here wants those. We try to avoid it because very few people on our team actually know Windows that well. Like I haven't touched Windows in quite a few years. It does make sense because you don't need that small VM layer on your Windows versions. So you can run those natively then without the VM layer. We still don't really have any plans, at least for now, to release Windows-based images just because it's not really our ecosystem for most of us. Okay, so that was it for the Docker side. Like this was just like, how do you build the right images and how do you make sure they are ready for production for the next step? Next up, Docker Compose. Probably not that many of you are using Docker Compose, especially not in production, maybe for local development or demos. I do that because it's quick and easy to run. So for example, this one would be the minimal example of running one single Elasticsearch node in whatever version with small heap and 1 gig of memory for the entire image, Kibana linked to it, and then we have a persistent volume to keep the data. So that would be probably the minimal example of what you could use to run Elasticsearch plus Kibana on Docker Compose. Simple enough, doesn't have many dependencies. So that will work and that works for demos, but it's not really much more. We used to have like a demo project, which we called Stack Docker, which had everything there, but we deprecated it because it was just not really worth the effort in our opinion anymore, because we want to focus more on that production experience. So I assume if you use any orchestration, most or all of you will be using Kubernetes. Normally with the show of hands, lots of people probably raise their hand for Kubernetes. Sometimes to that degree that it's not really the question is like, Kubernetes is not the question anymore. Doesn't really matter what the question is, Kubernetes is the answer. And that's always what you will be getting. When I ask like Swarm, sometimes people still have that, but it's oftentimes more on the way out and people try to migrate off of it. Nomad is also not very common in my experience. Mesosphere is pretty dead by now too, so probably nobody here. So we are stuck with Kubernetes. and I assume most of you or all of you are aware of how Kubernetes works. I'm not going to bore you with the Kubernetes introduction here. It's a static configuration to deploy your resources to Kubernetes. And this is the graphics that you all know. So you have your master node with the API server that you interact with. And then the main discussion point is always like, how do you pronounce this one here? I'll stick to kubectl for today. I always tend to pick a different one every day to keep it interesting. And then you have like the kubelets where you actually run your workloads. You have your data store that keeps the state of your API server, your scheduler, and then the controller manager that manages what is up and running here. So that's the base architecture that you have in Kubernetes. What you get lots of with this is YAML for better or worse. Yeah, lots of YAML. Some of us are probably already writing in their resume that they're YAML engineers nowadays because all they do all day long is write YAML. YAML is surprisingly tricky. It's a much bigger spec than you would expect, and it can bite you in the most unexpected ways. So for example, if you run this piece of code here through a YAML linter, does anybody know what happens here? And this is actually an example from the Docker documentation because this is kind of infamous. So what we're trying to do is we're trying to map port 80 to 80 from container to host and 20 to 20. So this is what we're trying to do here. When you run that through a YAML linter, you will actually map port 80 to port 80, but port 20 to port 20 doesn't work at all because it gets down to this weird number. Because anything with colon smaller than 60, YAML assumes that this is base. So rather than having port 20 to port 20, you have something base 20. And that's how you get to this nice number here. Just because that's in the YAML spec. And well, Docker actually warns you against doing that. And you should always quote those mappings. If you don't, you're in for a surprise if you're using any low port numbers. The other thing or other bigger problem we had that with Kubernetes was that it did not allow dots in environment variables until 1.8, which admittedly was a long time ago. Since then, you can generally use Elasticsearch on Kubernetes because we configure lots of stuff through environment variables which contain dots, which is generally perfectly legal. Just Kubernetes didn't support that for quite a while. But once that was fixed, since then we have been all good. So how do you run all of this on Kubernetes if you don't want to write all of that YAML by hand yourself and do stupid stuff like if you have a list of countries and then you have DE and US, whatever, until you get to Norway, which is NO, which would be evaluated like as a falsy value in YAML. Because it's, I think, one of 13 ways or so to write truthy or falsy values in YAML. Just one of the many aspects where it might surprise you if you write too much YAML by hand. So Helm charts or Helm is a package manager. So it is like package manager in like a regular package manager. You have a template and you can just create the basic Kubernetes resources that you already know and have, and you just can template them to move them to a state that you want to have. So you have your stateful sets, your services, your deployments, all the concepts that you already know and have. You can just reuse them, so it's not adding any weird complexity on top of that. We have official Helm charts, which are GA by now, so production ready and supported for Elasticsearch, Kibana, Firebit, MetricBeat, APM server, and Logstash, so you can just use them. What do they use? Generally, like most other data stores, they use stateful sets in the background. So you have a stateful set that you get some volume, or you can attach a persistent volume to that. And then you can just do stuff like a rolling upgrade, or when a pod dies and you need to reattach that volume, you don't have to re-replicate the data all over your nodes. You can just reattach a volume. So that is very helpful. For example, if you do an upgrade of your cluster, you can just do a rolling upgrade. You replace one node after the other. You reattach all the data, so you don't have to re-replicate 100 gigs or whatever you have in data. Wait until the cluster is all green and okay again, and then you replace the next node. So that's how you could do a rolling upgrade based on stateful sets. And this is what most data stores actually do. Our Helm charts are only tested on Google Cloud for now, using the default PD SSD storage, which is network attached, but you can also use local volumes. So that is kind of the generally tested setup there. What is kind of important to remember around the Helm charts is that they are unopinionated. So you have environment variables and you can mount secrets, and there are multiple upgrade strategies. So all of that is pretty much what you have just from the plain Docker images. It's just wrapped in a template. But you will, for example, if you want to set TLS encryption between your nodes or for communication outside of your cluster, you will need to generate the certificates and then you will need to mount them. Or if you create any passwords, you will also need to generate them in a key store and then mount them so your cluster can use them. So it builds heavily on the concepts that you already know from plain Docker. And you can configure lots of stuff through environment variables, which can look something like this. So for example, I'm picking the Minikube example. I'm not running it live here because with Zoom, this would probably take a full hour until everything is up and running because it eats all my CPU. So what you would do is you could add the Helm repository that we have, and then you install it, providing whatever image name you just want to run today. With Minikube, you might have to add some storage providers, and then you can just run this. And you can see the people who have been building this are using Make because they're kind of like the old school infrastructure folks at our company who are very much into like the tried and tested tooling. So that's why they are big on Make, for example, and why we're using this here. So what a very small example could look like is we have a container with half a gig of memory and a bit of CPU. We give it very little heat, and we also create a volume claim with 100 megabytes, which is also tiny, but for a hello world should be enough. The one thing that is sticking out here probably is, and that only makes sense for Minikube, is we have Affinity Soft, which basically means if you want to run multiple Elasticsearch nodes, this would allow it to do that on the same physical machine, which generally you would want to avoid. So you don't want to have the affinity to run multiple machines on the same underlying hardware, because if that crashes, it takes down all the nodes there. You would want to spread it out. With Minikube, there's no spreading out. So that's why we keep that affinity to soft and run everything on one or the same host. And that's pretty much it for Helm charts. So Helm charts are like a package manager. You say like install this version or bring me up 3 nodes of Elasticsearch. And it does that. And once it's done, it's done. Now let's move on to the operator. Operators are interesting because they kind of like move you one level higher on the abstraction. So it basically extends the Kubernetes interface and allows you to customize resources. So rather than thinking in pods and services and deployments, you think in elastic terms. So you can think in, I want an Elasticsearch service, and I want a Kibana service, and I want an APM service, and they have their own namespaces. For those, we have the so-called custom resource definitions, CRDs, and they provide these higher level abstractions rather than relying just on the known Kubernetes concepts. By the way, one thing where I'm also sometimes not very exact is you have the custom resource, which is basically the running living thing that you actually use. And the CRD, the custom resource definition, is like the class. If you're coming from the object-oriented world, that's the class, and the actual thing, the object, is the custom resource. The CRD is really the definition of what is possible and what you can run. And the custom resource is what you are actually running then in practice. And to bring those custom resource definitions to life, you have a so-called custom controller. So that's some code that we have written for you, written in Go, which is the most common, but there are also ways to write it in other programming languages, and that will manage everything for you. And this custom code will run in an infinite loop, the so-called reconciliation loop, which will continuously check in what state is your cluster right now, what is configured, if the two are different, how do I move your cluster into that state that you want it to be? And that is the main difference to Helm charts. Helm charts are like do X, and then it moves, I don't know, it scales up your cluster, or it moves it to that new version. Whereas the custom controller continuously runs and will also pick up like, oh, a node died, so I need to replace that. Or whatever else is configured in your cluster, it will continuously make sure not just moving it from state A to B, but always continuously checking, is it in the desired state, yes or no? And it will also manage a lot of things for you. So it will create secrets, it will create TLS certificates all automatically for you. There used to be an operator from the community, but the author or creator and maintainer was not able to run that anymore. So we provide our own, which has this fancy, colorful logo. I'm not going to dive into the logo too much. And that gives the operator. Don't be confused. Internally, we call it Cloud on Kubernetes just because it should give you like a cloud-like experience on Kubernetes. If you're searching for operator, you might not find that immediately. So don't be confused. There is an operator. It's just called Cloud on Kubernetes rather than Elastic Operator, which I think would have been the easier name and what is used by most others, but that's the naming that we're using. It can use Elasticsearch, Kibana, the Beats, and APM server. All of those can be managed by the operator. It's built in Golang, KubeBuilder, so that's the SDK to talk to the Kubernetes API server with the custom resource definitions. If you're using a very old Kubernetes version, we might patch that up with Kustomize to actually support or build around missing features. So that will just patch things together the right way to make them still work. So how does that generally look like? You, as the operator, you install the Elastic Operator, which continuously runs. So this has these custom resource definitions. This is the piece of Go code that continuously runs. And then you provide the configuration of what you want to have. And then that operator checks, okay, this is what you want to have. This is what is currently running. If those two are not the same, it will check like, how can I move the actually running cluster into the state that you want to have? So if you say like here, there should be 3 Elasticsearch nodes and 1 Kibana node, and then one of the Elasticsearch nodes one of the Elasticsearch nodes dies, then it would add another 3rd node again and bring the cluster back into that state. So this is what it would do. It continuously checks, this is what you have configured, this is the state you want to have. If you make any update to this, the operator would automatically pick it up and then move your cluster into the state that is configured here. So that's the general idea. And the operator is opinionated, and depending on how you see that, that might be good or bad. So it is opinionated because it encodes best practices. So for example, security is always enabled. It will always generate TLS certificates for you. It knows how to run an upgrade process and does specific operations for you. And the operator will talk to both like Kubernetes as a concept and Elasticsearch. So for example, if you have like 5 Elasticsearch nodes today, and you say, I only need 3 anymore, I want to scale that down to 3, it will not only talk to Kubernetes and actually kill 2 of the pods that you're running, but it will actually first talk to Elasticsearch and figure out, okay, these are the 5 nodes that I have. I will move all the data off 2 of these nodes and drain them. Only once they are drained, then I will run the Kubernetes commands to actually remove the underlying pod. So it does talk both to Elasticsearch and to Kubernetes. So that's what the operator does. And it encodes those best practices into all of those operations. So like I said, if you scale down, it will drain nodes first. If you upgrade it, it will set some configurations to actually make a smooth upgrade experience so that the cluster doesn't go crazy until like, oh, a node dies, I need to replace that node. Rather, it will make the right configuration so it says like, okay, I know that I'm being upgraded, so I will not try to replace that node because I know it will come back in a newer version in a moment and join the cluster again. Stuff like that is built in. But it is not guaranteed to be foolproof. So for example, if you have a single copy of your data, you do a rolling upgrade, every single node needs to go down and come up again. if your single copy of data is on the current node that is being replaced, your data or that data will not be available for a short amount of time. There's no way around that. There's no magic. So this is just the way the operator is built. It will try to protect you from stupid stuff, but if you have a single copy of data and you currently upgrade that node or the node dies, well, then that data will not be available until the node comes back up again. To run that on Minikube, locally, if you want to test that, I'm normally using K3s because it's much more lightweight and totally does the job. We don't officially test on K3s, but when I use it, it works. So especially for demos or hello worlds, K3s will be fine. Probably I haven't tested the Kubernetes in Docker yet, but I assume that it also works, which also should give you a much smaller or smoother experience than Minikube, which can be quite heavy, or it's pretty heavy for my laptop at least. So you assign some resources, you start it, and then you install the operator. So you can download it. Currently it's 1.2.1, 1.3 is coming out soon. We have the all-in-one operator, which covers all the pieces of software that we have here. You can actually watch the operator come up. So there is one part that is the operator that is running that Go code that runs the reconciliation loop. And then it will bring up all the other pieces that it needs to run. So it will create the TLS certificates and the secrets. And then it will bring the Elasticsearch nodes and Kibana and APM and beats and whatever else you have. The next 3 slides will show the configuration, APM, Elasticsearch, and Kibana. We'll start with Elasticsearch because that's what everything else is building on top of. So what I'm doing here is, and this, by the way, is where that concept of thinking in terms of elastic concepts and not anymore in Kubernetes concepts comes in. Because here in API version, I have Elasticsearch Kubernetes version 1. So this is an Elasticsearch resource. It's not a Kubernetes resource anymore, it's an Elasticsearch resource. And the name is Elasticsearch sample. This is also the metadata name that we will reference when Kibana needs to connect to Elasticsearch. And then you just say, okay, I want to have this version with a single node, these specifications, it's a data node, and this is like what I give it in storage. This is pretty minimal, and you can make this much more complex. You could split up nodes or node types, like we have dedicated master nodes and data nodes and maybe ingest nodes. You could split all of those up. You would get a lot bigger or a lot more YAML for that and a much larger YAML template to fill. But it is very finely configurable or tunable to your needs. This is just a very simple example here. Then I'm also adding APM for tracing and Kibana. So this does pretty much the same thing as before. You can see again, we are in an APM namespace and not in a Kubernetes namespace anymore. And it references the Elasticsearch sample from before and just brings up one stateless APM server. And pretty much exactly the same thing for Kibana. Again, its own namespace, same version, a single node, and references those Elasticsearch nodes that are running. And then you could, for example, check them out. There's nothing special here. You could expose the default port of Kibana so you can connect to that. And then you could extract that secret, which is always a joy to type unless you can copy it. But this is how you would get the password to actually connect to that Elasticsearch or to log into Kibana. So here you expose Kibana, the UI tool basically. The default user is Elastic. And then you need to extract the password because we will randomly generate the password for you. And that is stored in the secrets in Elasticsearch sample. So this was the metadata that we gave to that cluster. And then it's the Elastic user that we want to get from Elasticsearch. And then it's in JSON structure, data Elastic. And then it's base64 encoded. So this is how you would retrieve the final password to log into Kibana actually. But the TLS certificate is being generated and the password is being generated for you. The TLS certificates, by the way, are of course self-signed because, well, we cannot set up properly. We don't even know what external DNS name you would use. That's why we only provide self-signed certificates. If you know the DNS entries, how you will access your clusters, you can of course provide your own certificates and replace the ones that we would generate. So you have valid certificates. That's also totally possible there. And then if you change anything, you upgrade the version, you increase or decrease the number of nodes, anything you do, you just change the configuration, kubectl apply, the operator will pick that up, and then in the reconciliation loop, apply those changes and bring up the cluster in whatever state you want to have. And this is pretty widely tested. So we support that on Google, on Azure, on AWS, on OpenShift. Those are all tested nightly. The tests fail every now and then because I see it in the Slack channel, but we are pretty quick at fixing those, especially around releases then. And again, the concept behind that is a stateful set. So when you do a rolling upgrade, it will just reattach the volumes. So you have a stateful set per node role. So you have one stateful set for the master nodes and one for the data nodes if they're split up. And then there is a persistent volume for each pod that is running. So you can just reattach that when a pod dies or you replace it because of an upgrade. So that's what you can do there. Storage-wise, we support persistent volumes, either local or whatever your cloud provider provides, like AWS uses EBS or whatever they provide. You could also use mtdr or host path, which is not durable. So if the pod restarts, the data is gone, and it might be evicted because of the way quotas are enforced. So that is only really useful for ephemeral data. So if you use it more like a cache or something like that, which is very uncommon. Like persistent volumes are in 90% of the cases or so what you will want. In the future, we might officially support other storage backends. There is a Kubernetes specification for CSI, Container Storage Interface. We might dive more into that. So far, we haven't really, because there was not so much demand for that. Deployment-wise, you need to have admin level privileges to install a custom resource definition. So unfortunately, not unfortunately, of course, we need that as well. The one thing that we do right now is the operator sets max map count so that we get enough resources for our Elasticsearch instances. If we should do that, or if we should make you do that manually, is still a bit up for discussion. So to run the operator, there are two ways basically that we or any other operator that supports that can run. So you can have a global namespace for the operator. So we have the Elastic system namespace just for the operator, and nothing else is running in that one except for the operator. And then it manages all the other namespaces and checks, do you have that Elastic namespace anywhere? So do you have any Elasticsearch, Kibana, or APM servers running in any of those? And then it will pick that up and make sure you have configured X and running is Y. Are X and Y the same? If not, I will move them to that state. Otherwise, I will just leave it alone. And so multiple teams can run their Elastic resources in their namespaces, and a single operator will take care of that. Obviously, that operator then needs a lot of privileges across all the other namespaces, which you might not want or might want. It has the advantage that you cannot accidentally delete the operator. Whatever you delete on the non-operator side, basically, the operator would automatically recreate or replace them. So if you delete any pod accidentally, for example, the operator would figure that out and replace or stand up a new pod for you and take over. That is the Helm chart, in contrast, of course, doesn't do that. It just moves you from one state to the next. But the operator would figure out, okay, you accidentally you deleted one pod here, and it would automatically replace the pod. And running the operator in its own namespace is kind of like isolated from accidents against that. The other approach would be to run an operator per namespace. So then this operator here just takes care of these resources. This operator here takes care of these resources. Has the downside that you will need to run multiple operators, which will take up some or a few resources. It's not too much, but a little. On the other hand, you have a much nicer isolation between the namespaces, and there is no resource that is cross-cutting all of the namespaces. So that's another way to run that. Also, if you have like hundreds of clusters running, which some customers do, you will need to give more resources to that operator, or might want to split it up some other way. because that might be a very heavily loaded operator otherwise. Running it in individual namespaces might be a solution for that, but has some downsides as well. Also, you could, if you're just operating your dev team namespace and somebody accidentally deletes the operator, it's pretty much game over for the operator. So you don't want to have that. And there are lots of other operators, like Operator Hub from Red Hat actually shows you a wide variety of available operators that are listed there. So to wrap up, and I think, how are we doing timing-wise? Yeah, we have like 10 minutes or so. Containers are disrupting the industry is some statement that we hear every now and then. And I'm never sure if people mean that in a good or a bad way, because sometimes containers are being used wrongly or abused, and then they cause downtime. And that might also be that kind of disruption that people mean. The question that I hear quite frequently is, can I run Elasticsearch on Docker or Kubernetes? And the answer is yes. But the question that you should be asking instead is, should I do that? What did I say earlier? We don't have really strong opinions. If you run everything on Docker or Kubernetes within your company, probably go for it. And we try to support you as good as we can. If you're just starting out with containers, probably don't start with your data stores, because they are normally more tricky, because, for example, an upgrade strategy is much more tricky, or you need to think about backups. Stateless applications are probably the better place to start with that, actually. And then finally, something that we kind of like noticed after some time, after having that operator, or first not having an operator and then adding an operator, was the Kubernetes Paradox. So people would always ask, like, do you have an operator? And when in the past we said, no, we don't have an operator yet, they would say like, oh, this is a blocker, we cannot use your software. And then it turns out, when you actually ask, like, so you run the majority of workloads on Kubernetes, they're like, no, we're just actually starting. So we only have 2% of our workload on Kubernetes running, but we still expect everybody to support Kubernetes. Otherwise, we cannot use their software anymore, which was kind of like a bit of a paradox. Like, it was a must to have an operator, to have a good strategy there. But it doesn't mean that everybody will jump on the operator right away. So while we have some large customers on the operator already, it's not that everybody would be running Elasticsearch or probably any other data stores just in Kubernetes. It's just not what is happening. Helm charts versus operators. I hope I'm kind of made the difference clear. Maybe it's a good way to think about it, that Helm charts is like running stack on Kubernetes. And then the operator, that's also where the name comes from, is more like the cloud-like experience. It's like more operational best practices and automation built in. You just flip the version in the YAML file, and then it will do the rest for you, hopefully. Helm charts are not really opinionated, so you can run them multiple ways, whereas the operator is very opinionated and has all of that, like a streamlined approach. If you run lots of services and you want to kind of like run them your way, maybe you will have an easier time with the Helm charts. Whereas the operator just runs the stuff the Elastic way, which might be different than other operators. And maybe that is freaking your ops team out. Final point, what is the most tricky part about especially data stores on Kubernetes are like the day two operations. So it's like scaling up and down, upgrading versions, applying some configuration changes. That standing up something initially is not really the tricky part. But those day two operations, like keeping your cluster healthy and up and running and up to speed for whatever you need, that is the tricky part. And that is where the operator mostly comes in to try to help you and help with that operational best practices that is encoded in all the Go code that we are writing and maintaining, so you don't have to. So that's kind of like the idea here. That's it. I think we have like 5 minutes or so for questions and discussions. If you want to get the slides, that's the right QR code, or I can just share the QR code on Twitter afterwards. I guess it's time that I stop sharing and we jump to the questions.